A vast and infinite universe has always held secrets beyond our wildest imaginations, and often these enigmas prevent the sharing of information crucial to the advancement of science. Recently, the most advanced telescopes have detected a phenomenon that defies all logic, a cosmic mystery that has left scientists around the world perplexed. Findings from the James Webb Space Telescope have called the Big Bang Theory into question. Joel Rohn takes a deeper look at this telescope's latest discovery, which has revealed the shocking disappearance of 900 trillion stars. The $10 billion James Webb Space Telescope has been operational in space for over 2 years, but the results already prove that its investment has been worth it. The telescope far surpasses Hubble, providing unprecedented views of deep space. In July 2022, James Webb began exploring extremely long wavelengths coming from distant galaxies, detecting radiation outside the visible range, known as redshifted ultraviolet. The telescope has revealed astonishing details that were beyond our expectations, showing areas of space that Hubble could not observe. Most disturbingly, however, James Webb has discovered the unexplained disappearance of 900 trillion stars in the vacuum of space. This finding raises disturbing questions about how these stars could have disappeared without a trace, and each new piece of data adds an air of mystery and concern. In a surprising observation, the James Webb Telescope has detected the disappearance of trillions of stars without a trace. The question is, where have they gone? There are two main theories about this phenomenon. The first suggests that the stars are still present, but their death could have been accompanied by a lowered luminosity, perhaps hidden by dust, or that they have simply collapsed into black holes without going through a supernova stage. The second theory is more alarming. It could be that the universe is in a process of disappearance that we cannot stop. Almost a century has passed since scientists theorized that the universe was expanding and that the most distant galaxies appear to be moving away from us at an ever-increasing speed. This expansion does not mean that galaxies are physically moving through space, but that the fabric of space itself is expanding, leading galaxies to move away more quickly. This model, which has been dominant since the 1920s, has recently been revised. Only 20 years ago, it was discovered that this expansion is accelerating. As time goes on, galaxies are moving away from us at an ever-increasing speed, becoming unreachable even if we were traveling at the speed of light. When we look at the stars whose light has traveled for 100 years to reach us, we are seeing that star 100 light years away. However, when we look at a galaxy whose light has traveled for 100 million years, we're not looking at a galaxy that is 100 million light years away. In fact, that galaxy is even farther away. The reason for this is that, on larger scales, such as galaxies in clusters, the expansion of the universe plays a major role. The longer it takes for light to reach us, the farther away the galaxy is due to the expansion of space. This phenomenon manifests itself as a redshift. As light passes through expanding space, it stretches and changes its wavelength. If the universe were not expanding, the wavelength of the light reaching us would be constant, but due to its expansion, the wavelength stretches, causing the light to be redshifted. The significant redshifts we have observed in the most distant galaxies strongly confirm that the universe is expanding. However, our task goes beyond simply verifying this expansion. We can use the information gathered to understand how the universe has changed over time and what it is made of. A distant cosmic source travels to the expanding universe. Its wavelength is stretched, producing a redshift. This effect is more pronounced for objects that are farther away since their light has been traveling for much longer. By measuring the redshift of various sources at different distances and comparing their size and intrinsic brightness to what we can observe, we can reconstruct the full history of the universe's expansion. In addition, the way the universe expands is determined by the different types of matter and energy present in it. This allows us to learn about its composition. Approximately 68% of the universe is made of dark energy, equivalent to a cosmological Constant. 27% is dark matter and about 4.9% is protons, neutrons, and electrons. Only 0.1% is made of neutrinos and antineutrinos, and 0.008% is photons. No other entities, such as cosmic strings or textures, are found. Knowing these components with such precision allows us to apply the laws of gravity according to Einstein's theory of general relativity to predict the future fate of the universe. In doing so, we discover that the universe is dominated by dark energy. This finding implies that galaxies that are not gravitationally bound to us will eventually move away at an ever-increasing rate. As the universe continues to expand unchecked, the distance between us and those galaxies will increase, making them appear to be moving away at an increasing speed. This leads to an even more disturbing conclusion. At a critical distance, the fabric of space itself expands the distance such that a photon leaving our galaxy for a distant galaxy will never reach us. The expansion rate of the universe is so rapid that distant galaxies are becoming unreachable to us, even if we could travel at the speed of light. Although those galaxies are only 18 billion light-years away, the overall expansion is still increasing, and the density of matter and radiation continues to decrease. Our observable universe is about 46 billion light-years across, and if we consider that all regions of space contain an even number of galaxies, only 6% of all galaxies in the current universe are accessible to us. This means that even if we were to travel at the speed of light today, we would only be limited to exploring a small fraction of the universe. Furthermore, between 20,000 and 60,000 stars go from reachable to unreachable every second. Although the light emitted by these stars a second ago will eventually reach us, the light they emit in the present never will. This fact is unsettling, but it also reminds us of how precious every moment is. From a more optimistic perspective, this reality reminds us that if we ever want to travel beyond our local group of galaxies, which includes Andromeda, the Milky Way, and about 60 satellite galaxies, every second that passes is a lost opportunity. Of the estimated 2 trillion galaxies in the current universe, only 6% are still accessible from the Milky Way, and this percentage is still decreasing. This means that 94% of the galaxies in our observable universe are already out of reach due to the accelerated expansion caused by dark energy. As time goes on, every galaxy outside our local group is destined to move even further away unless we develop the ability to travel to other groups and clusters of galaxies. Otherwise, humanity will remain trapped in our local group, and our ability to send or receive signals from the various parts of the vast cosmos will fade away. The accelerated expansion of the universe is relentless, and the gravity we possess is not enough to counteract it. The universe is constantly expanding, and unfortunately, there's nothing we can do about it. If you like the video, give it a like and subscribe. This helps us continue creating the best content.